Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing your assessment for extended candidates and you have part 2. Kindly you can check part 1. We will continue our questions. We have 20 questions. Now we will start by question 11. We have a measuring cylinder contains 30 cubic centimeter of a liquid already here, and we added liquid until the liquid level reaches 50. So please, this question seems to be simple, but it's challenging. When you are using the equation for calculating density, please check that you are using rho is density is equal to mass divided by volume. When you substitute here, kindly check that you are substituting mass of a certain volume of liquid. So when you substitute, you will substitute here the mass of this added liquid, which is 30 grams, and you have the volume of this added liquid, which is the difference between reading 50 and reading 30. So it is 20 cubic centimeter. So your answer will be 1.5 grams per cubic centimeter. Check that you have consistent units. So the answer of this question will be C. Question 12. We have here a liquid and it has a volume and a mass. You have to substitute directly in using the equation. So density is equal to mass divided by volume, but you have to check that you have consistent units. So the mass here is 30,000 grams, but the unit of volume is cubic meter. How can you convert if you have different units? So you have to convert cubic meter to cubic centimeter, or if you have all the answers, if you check all the answers, have kilogram per cubic meter. Okay, so you have to convert grams to kilograms. So you have to multiply by 10 to the power of negative 3. So your answer here will be multiplied by 10 to the power of negative 3. Check also that you can use scientific notation. The answer will be 30 kilograms divided by 0.040 cubic meter. The final answer will be 750 kilogram per cubic meter. Your answer will be C. Question 13. You have a measuring cylinder containing liquid is placed on top pan balance and the apparatus is left overnight. Some of the liquid is evaporated. What happens here? You have to calculate the density of this liquid. Okay, one of the common mistakes, you have here mass, you have here the reading of the measuring cylinder will be the volume. one of the common mistakes students directly they substitute density will be equal to mass divided by volume. So they will substitute 350 grams divided by 250 cubic centimeter, and they got the answer. And you will find, by the way, you will find the answer here, but this is wrong. Why? Because this is not the mass of the liquid. This mass including mass of liquid and mass of measuring cylinder. Okay, so this will not be used. You have to find the mass of the liquid only and the volume of the liquid. Okay, so you have to substitute density is equal to mass divided by volume. When you subtract the two readings of the balance, you will find the mass of evaporated liquid. Okay, you will find the mass of evaporated liquid. So when the liquid changes to another state, you can find the mass here by subtracting 350 minus 343, and also the reading here of volume, 250 minus 242. The answer will be 7 divided by 8, which is 0.875 grams per cubic centimeter. Question 14, we have a student carries out an experiment to find the mass and volume of 4 samples of rock, different samples. Which pair are samples of same density or same type of rock? Same type means same density. You know that density is an intrinsic property. What do you mean by intrinsic? It's a physical property, it's a natural property of material. If you have two rocks made of same material, so the density of these two rocks will be the same. Okay? Here we have graph and we have values. We have mass on the y-axis and we have volume on the x-axis. What can you tell from this graph? You can, if you join these 2 points passing through the origin, so you can say mass and volume, they are, or you can say that the volume is of this object is directly proportional to its mass. Let's write it here. The volume of the object is directly proportional to its mass. And also you can tell the gradient of this straight line will give you the value of density. Let's check. If you sample R, if you just substitute mass divided by volume, 100 divided by 50, the answer will be 2 gram per cubic centimeter. For sample Q here, 200 and 100. The answer will be also 2, which means sample Q and sample R, they have same density. So they are made of same material, they are the same type of rock. Question 15. We have here liquids P, Q, and R. They have different densities and they do not mix. Okay, and we have a small block dropped into the measuring cylinder and comes to rest as shown. Before reading which statement is the correct one, let's write here what we can tell from the diagram. Number one, your observation that density of the block seems to be greater than density of Q because it sinks. Also, density of this block is smaller than density of P because it floats in P, in liquid P, right? Which statement about the density of the block is correct? Let's check the first statement. It's equal to the density of Q. No, it sinks in Q. Its density is larger than density of Q. It's greater than density of P. Its density is greater than, no, its density is smaller than density of P. Okay? It's greater than density of R here, right? Its density is greater than density of R. It's less than the density of Q. No, because its density is greater than density of Q. So the correct answer here is C. Okay? Question 16. We have a steel ball bearing has mass of 24 grams. Its density is given. It's lowered into a measuring cylinder containing 12 cubic centimeter of water. What is the new water level here in the measuring cylinder? Okay, so here you have to rearrange your equation. Density is equal to mass divided by volume. You are trying to calculate volume, so rearrange. Volume will be equal to mass divided by density. What is the value of mass? The mass of the steel ball bearing, it's 24 grams. And density here is 80 gram per cubic centimeter. Check that you have consistent units. The answer will be 3 cubic centimeter. This is not the answer. Please take care. It's written here, but this is not your final answer. You are trying to calculate the new reading, not the volume of the ball, the new water level. Okay, so you have here the measuring cylinder. It contains 12 cubic centimeter already. So here you have measuring cylinder. It contains here 12. Okay, when you add this steel ball, it rises 3, so the answer will be 15. Okay, so your answer is 15 cubic centimeter. Is it clear? Question 17. The density of air is 1.2 kilogram per cubic meter, and you have dimensions of a certain room, and the question is asking you to find the mass. Also, you have to rearrange your equation. So density is equal to mass divided by volume. Rearrange. Mass is equal to density times volume. Density is given already. Check that you have consistent units. All dimensions are given in meters, so it's very simple. You have just you have to calculate your final answer. Your final answer will be 72 kilograms. Your answer is D. Question 18. You have 2 cylinders are made of the same metal. This information is very important. Why? Same metal means same density. As we said earlier, regardless the shape of the object or how big the object is, since if you have two objects, they are made of same kind or same type of material, same type of metal, so it means they have same density. Because we said density is an intrinsic property. It's a physical property. Okay? Can you tell me what are the factors affecting density? Can you guess? Temperature will affect density, right? Why? Because temperature may change volume. Temperature, it will change volume. Density is equal to mass divided by volume. Temperature will not affect mass, so mass will be constant in this case. So if the volume increases, if the object expands, so increasing volume will decrease the density. So at constant mass, density and volume, they are inversely proportional, and one of the important factors affecting density is temperature. So temperature if temperature increases, maybe the object will expand and it will change its density. Okay? So the answer of this one, which quantity is the same for the two cylinders. One is longer, they have same cross-sectional area, but one is longer, so here they have different volumes, they have different masses, but still mass divided by volume will give you the same ratio. So they have same density. Okay? Question 19. We have two identical measuring cylinders and we have liquid X and liquid Y. So how does the density of X if you compare it to the density of Y? Okay, as we said in the previous question, here mass is constant. How do you know mass is constant? Because you have here using the balance. Okay, we have here pivot, you have here balance. So in this case you have equilibrium and you have liquid X, liquid Y, X and liquid Y, and they have identical measuring cylinders. So when you are comparing, it's a fair comparison. So if you are comparing liquids, they have same mass, but they have here different volumes. They have here different volumes. So density is equal to mass divided by volume. Here the mass is constant as shown in the diagram because we are using simple balance and they are balanced. What about density and volume? What will be the relation here? To keep the mass constant, as I told you, density and volume will be inversely proportional. Density and volume will be inversely proportional. So density is inversely proportional to volume at constant mass. Which one, using the diagram and measuring cylinders, which one here has greater volume? As shown, liquid X 200 cubic centimeter and liquid Y 100 cubic centimeter. So according to this relation, the density of X will be half the density of Y. Okay, so here volume is doubled, so density will be halved to keep the mass constant. So our correct choice will be A, density of X will be half density of Y. Why? Because volume of X is double the volume of Y. Is it clear? This question is challenging and is very important. The last question we have, question 20. When two blocks X and Y are placed on a uniform beam and the beam balances on a pivot, its center as shown, the pivot here at its center, what does this show about X and Y? Okay, here we do not have measuring cylinders. They are not liquids, they are solid objects, X and Y, and they are placed blocks and they are placed on a beam. What can you tell about X and Y? As shown, volume of Y is greater than volume of X. What about mass? Mass is constant because they are balanced here. They have same mass, same weight. Okay? So you have to exclude here C and D because they do not have same volume. So they have same volume? No. They have same volume? No. Okay? So here you are comparing density is equal to mass divided by volume. Mass is constant. Volume here of Y is greater than volume of X, but we have no idea about density. We have no idea about density. They have same mass and same weight. Okay, they have same mass and same weight. We cannot say they have same mass and same density. No, we cannot say they have same density. Why? Because they have different volumes. They have different volumes. This question also is very important and challenging.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.